Now we come on to generator functions, one of the most powerful and elegant features of the Python programming language. Python generators provide the means for describing iterable series with code in functions. These sequences are evaluated lazily, meaning they only compute the next value on demand. This important property allows them to model infinite sequences of values with no definite end, such as streams of data from a sensor or active log files. By carefully designing our generator functions, we can make generic stream processing elements which can be composed into sophisticated pipelines. Generators are defined by any Python function which uses the yield keyword at least once in its definition. They may also contain the return keyword with no arguments, and just like any other function, there is an implicit return at the end of the definition. To understand what generators do, let's start with a simple example at the Python REPL. We'll define the generator and then we'll examine how the generator works. Here we write a generator called gen123 which yields successively 1, 2 and 3. The generator function is introduced by def, just as a regular Python function. And as we've seen, we must use the yield keyword at least once within the definition. Here I'm yielding a value of 1, and then 2, and then 3. We'll enter a blank line to complete the definition, and there we are. Now let's call gen123 and assign its return value to g. As you can see, gen123 is called just like any other Python function, but what has it returned? G is a generator object. Generators are in fact Python iterators, so we can use the standard ways of working with iterators to retrieve or yield successive values from the sequence. To retrieve the next value from an iterator, we use the built-in next function, passing the iterator, or generator in this case, to the function. So next g returns 1, and again 2, and again 3. Take note of what happens now that we've yielded the last value from our generator. Subsequent calls to next raise a stop iteration exception, just like any other Python iterator. Because generators are iterators, they can be used in all the usual Python constructs which expect iterators, such as for loops. Here we call the generator again, and in each iteration of the loop we print the returned value. 1, 2, 3, just as we'd expect. Be aware that each call to the generator function returns a new generator object. Here we call gen123 again, assigning to h, and again assigning to I. We can see when we display these objects that they have distinct addresses. This means that each generator can be advanced independently. Let's request the first value from h, the second value from h, and now the first value from I. Let's take a closer look at how, and crucially when, the code in the body of our generator function is executed. To do this, we'll create a slightly more complex generator that traces its execution with good old-fashioned print statements. As we enter the generator, we'll print a message. Then we will yield 2, then print a message about yielding 4, and then yield 4, print a message about yielding 6, and then yield 6. Then at the end of the generator function, we'll print a message indicating that the function is about to return. A blank line to complete the definition, and now we can call our new generator, assigning to g. Note that at this point the generator object has been created and returned, but none of the code within the generator body has yet been executed. Now let's call the built-in next function on our generator. See how when we request the first value, the generator body runs up to and including the first yield statement. The code executes just far enough to literally yield the next value. When we call nextg again, execution of the generator function resumes at the point it left off and continues running until the next yield. And then the final value, the function resumes again until it yields 6. After the final value is returned, the next request causes the generator function to execute until it returns at the end of the function body, which in turn raises the expected stop iteration exception.